Yeah. Now I am taking the attendance. Okay. Okay. So yesterday we discussed about the introduction of laser. So today we will start with the characteristics of laser. Okay, so these are the most important characteristics of the laser. So compared to the ordinary light, so these four characteristics are there here. So these four characteristics separate with the normal light. Okay, separate with the normal light. So what is the main characteristics here? These four characteristics. First one is the monochromaticity, second one is the high degree of coherence, so third one is the high directionality, and fourth one is high brightness. Okay, first of all we will discuss about the monochromaticity. Okay, so monochromaticity is nothing but uh, single wavelength or single color. Single wavelength or single color. See here, laser light is monochromatic or very pure in color. The bandwidth of the laser beam is narrow, while ordinary light spreads over wide range of frequencies. The photons emitted in the stimulated emission have same frequency or wavelength. See here, I will explain you this sentence. So we said that if you draw the graph between the wavelength versus intensity. So intensity on y-axis, intensity of the light is on y-axis, and wavelength will be on x-axis. If you will take wavelength will be on x-axis. If you will take normal light, if you will take normal light, so that will be like this. It spreads. Suppose if you will take single color, if you will take single, suppose sodium is the, so generally monochromatic. If you will take sodium light is orange color. It emits the orange color. It is monochromatic. If you observe the graph between intensity versus wavelength, okay, that graph spreads over a width of wavelength. That means, so it's starting from here and ending from here, ending from the ended here. Okay, starting from here and ended here. So see here, suppose monochromaticity is nothing but single wavelength. But here if you observe, so there is a group width of the wavelength. There is a width of the wavelength, not a single wavelength. Suppose at the center wavelength will be 590 angstroms. If you will take yellow color, means it will be 590 angstroms. Okay, 590 angstroms. So but it spreads up to 570 to 570. Okay, 570 to, so 600, more than that also it will spread. So if you will take normal light, if you will take, it will spreads normal light. So that also monochromatic light only, monochromatic light only, normal monochromatic light, not laser light. So it spreads. So some wavelength width, it's not contain single wavelength, it's not contain single wavelength. It spread some wavelength width. That's why it's not exactly orange color. It's not exactly orange color. Okay, if you observe the laser light, if you observe the laser light, how it will be. So what is the bandwidth means? So width between the, so minimum, so here wavelength is starts, that means that peak is starts here, ended here. Okay, distance between these two wavelengths, so that is called as bandwidth. That is called this, that is called as bandwidth. Okay, here bandwidth in case of normal lights, so that bandwidth is very high. So normal light. In case of if you will take laser also some monochromatic lasers also there. That means red color laser, yellow color laser, blue color, sorry, red color LED, blue color LED, and other LEDs. So in LEDs also those are the normal lights only. LEDs also normal lights only. In that normal lights also this bandwidth is very high. Okay, so compared to sodium light, so LED lights have little bandwidth. So bandwidth is reduced, but compared to laser, so LED also having high bandwidth. LED also having high bandwidth. Now we will observe the in case of laser how bandwidth will be. Okay, if you will take laser, so that bandwidth will be very sharp. That bandwidth will be very sharp. Here also it will be. Okay, so that means it starts from here, ended from here. Okay, so that bandwidth is very small. The bandwidth is very small here. See, so this is the bandwidth. It started from here and ended here. Okay, ended here. So bandwidth between these two is very small. Bandwidth between these two is very small in case of lasers. In case of lasers, so that's why we said that this is monochromatic. So this is monochromatic. If you will take orange means exactly it will be 590 angstroms, 594 like that it will be there. So 590, approximately 590 angstroms in case of orange color. So for different colors it will be different wavelengths. Okay, so that means the width of the wavelength also either just so very range small range. Suppose if you will take here middle point is 590 means it is just 5, it starts at 585 ends at 595, ends at 595. So that means approximately just 10 angstroms width of the bandwidth is less than 10 angstroms, less than 10 angstroms bandwidth. But in case of normal light, here observe here, so ordinary light 1000 angstroms, so bandwidth is so 1000 angstroms. Okay, so that is regarding about the bandwidth. Okay, now coming to the second point. Due to stimulated emission of laser beam using a single wavelength, so because of the stimulated emission, we said that stimulated emission, because of the stimulated emission, so these laser having narrow bandwidth, and single wavelength. The line width of the laser beam is extremely narrow. Okay, so if you observe the ordinary light, that is about 1000 angstroms. So the bandwidth of the laser light is just about 10 angstroms. Okay, 10 angstroms. Next point, the narrow bandwidth of laser light is called high monochromaticity. So because of here, just we said that 10 angstroms. So due to that this bandwidth, less bandwidth, we said that here that laser having monochromaticity, high order of monochromaticity, high order of monochromaticity. So normal light also having monochromaticity, but that monochromaticity order is very high, but here sorry very less. Monochromaticity order is very less, but here so monochromaticity is a high order monochromaticity in case of lasers, because of the this narrow bandwidth, narrow bandwidth. Okay, what is the definition of bandwidth? So the spread of wavelength about the wavelength of maximum intensity is bandwidth. I said that now. So here this is the maximum intensity, maximum intensity of the wavelength. So it spread just 5 angstroms this side and 5 angstroms this side. Okay, so total spreading from here to here, so that is called as, so that is called as bandwidth, that is called as bandwidth. See here, laser light is more monochromatic than that of the conventional light source. Because of the monochromaticity, large energy can be concentrated into a extremely small bandwidth. So here, so large amount of light is concentrated on a small area, due to this reason, so here bandwidth is very small. Okay, now coming to the directionality. The laser beam emits light only in one direction because the photons emitted in the stimulated emitted process travels along the same direction or along the axis of the active medium. Already I said that. See here, if you will take the laser ordinary light means suppose this is the ordinary light here. In that ordinary light, so light will be emitted in different directions. Light will be emitted in different directions. It will be emits like this direction in all directions. Okay, all directions it will be emit. Suppose if you will take laser, if you will take laser light, so that light emits only in particular direction. That light emits in a only in a particular direction. Okay, so this uh, because of this direction, see here, so the light emits only in direction, one direction. Okay, only in one direction because of photons emitted in stimulated emission process. Okay, so I said that stimulated emission occurs. So because of that stimulated emission, all electrons will move in a single direction, sorry, all photons will move in a single direction. Okay, whenever electron will comes to the excited state to ground state, photon will be emitted. So those emitted photons will move in a single direction. Single direction. Okay, travel along with the same direction along the axis of the active medium. Along the axis of the active medium. So I said that what is the active medium? So in laser topic we will discuss about the active medium. Okay, now it travels very long distance without divergence, without without spreading. So divergence is nothing but, so here spreading of light. So without spreading, here they will travel long distances. And so laser communication is carried on between the earth and moon. Okay, if you will take normal light, if you focus normal light from earth to moon, okay, so its distance is so far, so distance is so far, so that's why it spreads so much distance, it spreads so much distance, so that intensity also very losses, intensity of the light also after reaching, so before reaching the moon, so what happened, the intensity will be decreased very less because it's spreading. So if you will take normal light, so normal light is traveling like this, suppose normal light is traveling like this means, so every point in normal light will act as a secondary source. Every point in normal light, suppose if you will take this point, so this point also will act as a secondary source. Secondary source means, so it also spreads light, so that means light will move like this direction, in all directions. Okay, all directions. From this point also light will spreads in all directions. Similarly, if you will take this point also, from this point also light will spread in all directions in case of normal light. That means in case of normal light, every point on the light wave will act as a secondary source, so that's why, so that light intensity will be decreases with traveling the more distances, as well as it spreads more distance. Okay, that is about the normal light. So that means divergence is very high in case of normal light. If you will take lasers, so the divergence spreading of the light is very small. Spreading of the light is, see here, so this is the laser light. So if you going the certain distance, so its spreading is very small. If spreading is very small. If you will take otherwise torch here instead of laser, so torch, so generally we consider that torch light also, so it will move only one single direction, but so how it will be spread, so torch light will spread like this, it spreads. So this is the torch, just imagine that. So torch also will spreads like this. Okay, so it spreads more distance. Suppose if you will take this point, it spreads this much of distance. Okay, if you increasing the more distance, it spreads also more. Okay, so that is in case of normal torch light. Okay, if you will take laser, so this laser spreads very small, that because the divergence is very small. Divergence is very small. So if divergence is small means we will consider as it has a more directional. Divergence is less means we said that, so that light is more directional, high directionality, high directionality. Okay, how we can measure the, so here del theta, see here, suppose a1 a2 be the radii of laser beam at a distance d1 and d2 from the laser, the divergence, so here divergence angle, how much laser will be diverge, how much laser will be diverge. So by using this formula we can calculate, so that formula divergence angle is equal to a1 minus a2 by du2 minus d1. What is the a1 a2? So a1 is the radii at a d1 distance, so from here to here distance d1. So here radii of the laser is a1 and here to here distance is d2. So here radii of the laser light is a2. So what is the divergence, what is the divergence angle means, so a1 minus a2, so radii of the this point minus, so radii of the this point, here actually a2 minus a1 will come, a2 minus a1, a2 minus a1 by, so d2 minus d1, d2 minus d1. Okay, so this is the d1, this is the d2. Here a1 is the radii of the laser, a2 is the radii of the laser at a d2 distance. So what is the divergence angle, del theta is equal to a1 minus a2 by d2 minus d1. Okay, this is the divergence, this is the divergence angle. If divergence angle is very small means we can set that, so that is the high directionality, so laser having very high directionality. Okay, understood? Yes. Now coming to the coherence. So this is also very important property. So so first of all we are going to the, what is the coherence. Two sources of light are said to be coherent if they have zero or constant phase difference between them. So coherence is nothing but how we will set that coherence means, how we will define the coherence means, so while comparing the two waves, so we said that here, so the two waves have zero or constant phase difference. So two waves are traveling here. If the two waves are have zero or constant phase difference between them, then we said that, so those two waves are coherent. Those two waves are coherent. Okay. See here, there are several examples are given. In case of sunlight. Sunlight is, it is not a monochromatic. Sunlight is not a monochromatic, so it will mixture of all colors. That's why. So there is a range of wavelengths. All wavelengths will be present in a sunlight, as well as so they are not coherent, so that's why if you observe the sunlight, so different waves will move in a different directions. So if they are moving also same direction also, so they are having different phase difference, different amplitude, as well as different wavelength. So what is the wavelength definition, anyone knows about? Distance between the two maximas or two minimas is called as wavelength. See here, so I will explain you in this diagram what is the wavelength. Okay, so this is the one maxima of the one light, so one wave here. So another maxima is here. So distance between the two maximas, so that is called as wavelength, or distance between the two minimas. So here two minimum points are there, distance between these two minimums, so is called as wavelength. Okay, so here the different, if you observe the different waves, so this maxima is here, this maxima is here. Okay, so see here, so this wavelength also different, this wavelength and this wavelength is different. Similarly, if you will take another wave, that wavelength also different. Similarly, phase difference, so phase difference also different. Okay, so in case of sunlight, it is not monochromatic, that's why it is having different wavelengths, as well as it is not a coherent. it is not a coherent light. So that's why here there is no constant phase difference. There is no constant phase difference. As well as amplitudes also different. Amplitudes also different. What is the amplitude? If you will take the mean position, so from mean position, so it will vibrate, that wave also will vibrate, so it will goes to the maxima as well as minima. So how much it will be vibrate from the mean position, that is called as amplitude. So from mean position it is vibrating this much high point, and it is so in lower direction, so it reaches to the this much high point. So this is the amplitude. So if you observe the different points here, so different amplitudes will be there, different waves having different amplitudes. Okay, so in case of sunlight, so amplitudes are different, wavelengths are different, as well as so phase there is no constant phase difference, that means they are incoherent, they are incoherent. Okay, that is in case of laser light. Now coming to the LED. LED having one color. One color means it is monochromatic. It is monochromatic. Monochromatic is nothing but wavelength is constant. So wavelength is same. See here. So this is the one wave. So this is the one wave. It's ended here. Okay. So this is the wavelength between the these this wave. So if you will take another wave, so this is the what is the wavelength from here to here? Okay, this is the wavelength of this wave, but so distance between these two, so from here to here is same, so here to here is same, so that means here wavelength is same, wavelength is same, but they are not in coherent, they are not in coherent. Okay, so they will overlap with each other, they will overlap with each other. Because of this overlapping, so there is a chance of diffraction, there is a chance of diffraction as well as interference also. Okay, so that's why so LEDs are not coherent. LEDs are not coherent because so that wavelength is same, wavelength is constant wavelength, all are having same wavelength, but so phase difference, there is no constant phase difference, they are incoherent, they are incoherent. Okay, now coming to the laser light. Laser light, see here, so wavelength of all laser light is same, wavelength of all laser light is same, so that's why those are monochromatic, those are monochromatic. As well as phase difference, if you will take, so this point, so this point, how much angle it will be the same. So if you will take, so this wave also same having same phase, so this also having same phase. Okay, so phase constant phase difference here, phase difference is constant. Okay, that's why we said that this is monochromatic laser light. So this is a coherent. So because of the wavelength, so we said that so these are the monochromatic because of the phase difference. Phase difference, that means constant phase difference or zero phase difference. Okay, so if they those are having zero phase difference or constant phase difference, we said that so that light have coherent light, that light have coherent light. So laser beam is coherent, laser beam is coherent. There are two types of coherences are there. So one is the spatially coherent, another one is temporally coherent. Spatially coherent and another one is temporally coherent. So what is the temporally coherent, what is the spatially coherent, we will discuss. Okay, first of all we will discuss about the temporal coherence. Temporal coherence, see here. Okay, temporal coherence. So what is the temporal coherence? Temporal coherence refers to the correlation between the light fields at different times at a point on the wave. Okay, so if you observe the different times, it is if we are taking here, so this is the one wave, this is the one wave I am taking at one point at different times, at different times. So what is the phase difference, what is the phase difference between that? Okay, suppose I am taking, so at suppose 0 seconds. So now Now I am taking here. So what is the phase difference here? So approximately your phase difference is, so how to calculate phase difference means, so this is the mean position. So light is traveling like this direction, so from that direction how much angle it will make. Okay, so this is making at p1 point, this is making angle like this. Okay, angle make like that. So this is the phase here, this is the phase here. Okay, so that phase different, that is the phase. So after certain time, after 10 seconds I will take now. So now 0 seconds we are taking initially, that's why 0 seconds. So at p1 point, so suppose approximately it is having uh, so it is having approximately 10 radians, 10 radians. So phase difference we can measure either theta or radians, 10 radians. So after time, after 10 seconds, after 10 seconds, what is the phase here, what is the phase? So after 10 seconds also, so 10 there will be a phase is 10 radians. 10 radians means, so we said that we have phase constant phase difference, we said that. So there is no change of phase, there is no change of phase. So up to certain time, so up after the okay, up to we are observing here up to 10 seconds, up to 10 seconds. Suppose if you observe at 15 seconds, if you observe at 15 seconds, so that phase is changes. So after 15 seconds it will be 11 radian, 11 radians, 11 radians means, so here phase is changed. So up to 10 seconds, so this what is that, phase is constant. Up to 10 seconds this phase is constant. So that's why, so so here see this, the temporal coherence refers to the correlation between the light fields at different times. So at different now and after 10 seconds. So at a point, at a point, so how phase difference will be, how phase difference will be. Okay, there is no change in phase over a time t. Up to 10 seconds there is no change of phase, there is no change of phase at a point, at a point, then it is said to be temporally coherent, temporally coherent. So up to 10 seconds here, so there is no change of phase, there is no change of phase. So that's why we can say that, so this wave is temporally coherent up to 10 seconds, this wave is temporally coherent up to 10 seconds. Okay, so this is about the temporal coherence. So now if you observe the two different points, p1 and p2 points, since the 2 points p1 and p2 are on the same wave train which is continuous, they have correlation. Okay, so see here, so p1 point and p2 point, how much time here there is a correlation between them. So that also we can say that. Okay, now, so this is about the continuous wave. If you will take discontinuous wave, discontinuous wave, discontinuous waves are not a temporally coherent, discontinuous waves are not temporally coherent. Okay, now spatial coherence, spatial coherence. Okay, if a wave maintains constant phase difference are in phase at two different points on the wave over a time t, then the wave is said to be spatially coherent. Okay, see here, constant time, that means at a time. So now I am taking, so just now only, so this point and another point I am taking 2 points. Okay, just now it is a time t. Okay, it is a time t, here also time t. Okay, so in the time t, so at the time t, that means suppose now time is 10:40, at 10:40. Okay, here wave phase is like this. So if you will take another point, this phase is like this, this phase is like this. So that means all waves are maintaining constant phase difference, all waves are maintaining constant. Suppose here phase is so 10, here phase is 9, so phase difference between them is 1. Okay, phase difference between them is 1. All waves are maintaining constant phase difference or not. Okay, at a particular time. So if you observe the two different points, so they are maintaining constant phase difference or not. If they are maintain constant phase difference, if they are maintain constant phase difference, we can set that those waves are spatially coherent. Okay, it, in a particular time, so if you will take the 2 points, in the 2 points all waves are maintaining constant phase, all waves are maintaining constant phase difference, constant phase difference. That means here phase is 10 radians, here phase is 9 radians, here phase is 9 radians, so phase difference between them is so 1 radian. Okay, so if you will take so 2 points at a constant time, those all are maintained only, so phase difference is 1 radian for all waves. All waves means we can set that, so those are spatially coherent, spatially coherent. Okay, see here. Spatial coherence refers to the laser beam output being narrow and resistant to diffraction, essentially retaining its narrow shape. Okay, because of the spatial coherent, what happened here? That beam will become narrow. So that means so at a long distance also, that phase difference is constant, means what we can set that, so that is not spreading much more distance, we can set that that is narrow, and resistant to diffract. Okay, so it is phase difference is same, means it is not diffracting, it is not diffracting. Okay, so that's why we said that, so here resistance also very high for diffraction, and essentially retaining its narrow shape. Okay, for long distance it will retain narrow shape. Okay, next point, this allows laser to be focused in a small spots, as well as reach large distances. Okay, see here, because of this narrow, that means a spatial coherent, because of this spatial coherent, what happened, so that will become, laser will become very narrow, laser will become very narrow, so it will focus on a small spots, it will focus on a, because of that narrow shape, it will focus on a small spots. Okay, if you will take incoherent, spatially incoherent, so spatially incoherent means, see here, so they are, if you will take two different points at a time, so this point and this point, so at a time t, so if you will observe the two different points, so those are on, if you will take this phase, this is phase difference will be so 2 radians, here phase difference will be 4 radians, here phase difference will be 7 radians, so like that, so there is a phase difference is very high, phase difference is very high here, so that's why these are not spatially coherent, so that's why we said that these are incoherent waves, spatially incoherent waves. Okay, now the maximum separation between any 2 points, on the cross section of the wavefront which maintain correlation between them. See, same whatever we discussed above point, the maximum separation between any 2 points on the cross section of the wavelength which maintain correlation between them. Okay, that means, so how much distance it will maintain constant phase difference, how much distance, that maximum distance it will maintain a constant phase difference, so that is here, so temporally coherent, so the, sorry, spatially coherent. Okay, so in which are in phase with each other all the time is called spatial coherence. So the spatial coherent also called as transfer coherence, spatial coherence also called as transfer coherence. Okay, this is the incoherent light wave and this is the coherent light wave, so lasers are the coherent light wave, so that's why, so they are moving, see here, very straight line. Okay, next one is, next property is brightness. Okay, already we know that, so what is the brightness? So when it will be high, very high brightness, so when we said that, so that light is very bright, so intensity of the light is very high, we said that that is very bright, if you observe the normal light, so what happened, intensity will be very less, Intensity of the light will be very less, because so in case of normal lights, that light is moving in all directions, light is moving in all directions. But in case of laser light, in case of laser light, so because of the stimulated emission, because of the stimulated emission, all waves are moving in a particular direction, all waves are moving in a particular direction. So that's why, so that intensity of the laser light is very high, intensity of the laser light is very high. So that's why we said that laser lights are very bright, laser lights are very bright. Okay, see here, already we discussed about the directionality. Okay, so directionality is very high, so that's why this also does not spread much more distance, so that's why, so intensity is very high if you traveling after large distances also. Okay, so compared to conventional light, those are having very high, so high brightness. Okay, because it's concentrated in a small region. Okay, it is observed that the intensity of 1 milliwatt laser, 1 milliwatt laser laser light, it is 10,000 times brighter than the sunlight, light from the sun at the earth's surface. If you observe the sunlight on the earth's surface, so if you say, if you will take 1 millivolt laser light, 1 millivolt laser light, so that 1 millivolt laser light is 10,000 times brighter. 1 millivolt laser light is 10,000 times brighter than the normal sunlight, normal sunlight. Okay, so see here how much intensity, how much brightness it will be, the lasers. Okay, now if you will observe the another example, the number of photons coming out from the laser per second per unit area is about approximately 10 to the power of 22 to 10 to the power of 34. Okay, so it's a number of photons coming out from the laser per second per unit area. If you will take, so small unit area, if you will take small unit area, in that unit area per second how many photons will emit? So 10 to the power of 22 to 10 to the power of 34, so that much of photons will be emitted. Okay, those all photons will move in a same direction, so that is another discussion. Okay, now, whereas number of photons coming out per second per unit area of black body, already in first unit we will discuss about the black body. If you heat the black body, what happen? It will emit the radiation. If you heat up to 1000 kelvin, 1000 kelvin is not a normal temperature, it is a very high temperature, it is very high temperature. At this temperature, very high temperature also, it will emit just 10 to the power of 16 photons, it will emit just 10 to the power of 16 photons. But in case of laser, at room temperature also, it will emit up to 10 to the power of 22 to 10 to the power of 34. Okay, so how much time it is greater? Observe here. Okay, so laser is that much of intensity, so because of that intensity, it's how very bright, it's how very bright. So intensity also very high, intensity is depends on the amplitude. I said that amplitude is very high, so intensity equal to I equal to square of the amplitude, intensity I equal to square of the amplitude. Okay, this is about the brightness here. Okay, so tomorrow we will discuss about the next topic. Okay, first of all I will take the attendance. Okay, if you have any doubts you can ask, otherwise you can leave from the session. 68 members are joined, na? Okay, you can leave from the session.
Thank you, sir.
Okay.